Hi, this is Merritt, and today we're going to talk about the spaces between molecules and how that affects measuring. What I'm going to use for my demonstration today is some colorful spherical cereal, some salt, some water, and rubbing alcohol. Both have different colors of food coloring, so they're easier to see. Another bottle for measuring, and a funnel. So let's start off over here with our colorful cereal. I'll try not to say its name, but spheres work best for this, little round balls. And you notice I have pre-measured in this 2-cup measure. This is a 2-cup liquid measure. There's about 1 cup of the cereal already, and the top 2-cup measure is up here. So I have another cup of cereal in my hand. If I were to pour it in to the glass measuring cup, 1 cup plus 1 cup, how much would you say I would have in the cup? Well, I know you would say 2 cups, and you would be right. I tried it many times. It actually works out that way. It would come about up to the 2-cup line in its lumpy, bumpy way. But that's too easy. Let's do something a little more challenging. Instead of putting in, for our 2nd cup cereal, let's put in some salt. This is exactly 1 cup of salt. Sugar and dry sand also works for this. Now, since 1 plus 1 equals 2, then 1 cup of cereal plus 1 cup of salt is going to come up to the 2-cup mark on the glass measure, right? Okay, let's see if 1 plus 1 equals 2. Oh, wait, something's not right here. Okay, you probably saw the rogue piece of cereal in there. With or without that piece of cereal, we didn't really get up to the 2-cup mark. There's only 1.5 cups of dry ingredients here. How is it that 1 plus 1 only equaled 1.5? Well, you're probably way ahead of me on this one. You probably realized ahead of time that the salt was going to fill in the spaces between the cereal pieces. And you might have been asking already, if I say I've measured a cup of cereal here, do I really have a cup of cereal? Can we count this as a cup of cereal when there are so many spaces in between? So it's pretty obvious with cereal and salt, but what about for liquids? Let's try the same thing with a couple of liquids. So over here, the blue liquid we have is water, colored blue. We have a 1/2 cup water, and I've colored some 99% rubbing alcohol yellow. 99% alcohol works best for this. And to give myself another measuring jar, I've pre-measured 1 cup. So we have a 1 cup line here. 1/2 plus 1/2 equals a whole. You've probably cooked in the kitchen and you know that 1/2 cup of water plus 1/2 cup of water is a cup of water. Let's see if that works for water and alcohol. Dyeing them different colors shows us something interesting, by the way. Notice that the yellow alcohol on top, it doesn't really want to mix with the water. It has to be coaxed a little bit. And if you swish it or stir it, it will finally, but it's going to resist. Once it's all green, you'll know that it's mixed. But look at this, just like the cereal, the liquid didn't come quite up to the 1 cup mark. Well, what's that about? Here we don't see any particles. Here we don't see any air spaces between any particles. But it turns out that alcohol and water are both made of molecules. Molecules are particles that are so small we can't see them. So even though we can't see them, there are particles with spaces in between within this liquid. And the water gets in between the larger alcohol molecules in the same way that the salt got in between the cereal pieces. So the question I'll leave you with, if somebody fills a bottle of water, is it full? Is it, if it's a liter bottle, is it really 1 liter? Is it any more full than a bottle or a liter of large pieces of cereal would be? Food for thought, signing off.